Bonjour, mesdames et messieurs. Buenos dias, damas y caballeros. Good morning, ladies and gentlemen. My name is Sang-Hoon Kim, and I'll be your MC for this event. I'd like to remind you that we're coming to you live, and over the next 2 weeks, we have 68 presentations from aviation industry professionals. For more information, please make sure to go to YouTube and check out the ICAO channel. If you have questions at the end, please make sure to approach the mic and fire away. Now, this is day 2, session number 4, and we just completed our presentations on big data, and now we'll be talking more about the drone industry. Now, we have quite a gift for you. I mean, we have one of not only the leading organizations in the private aviation industry, but also they're one of the biggest organizations in the world. We have the topic today is challenges and solutions for future air traffic management systems and unmanned aircraft system traffic. We'll have 2 presenters from you from Thales, Warren Beeston, Operation Authority Director at Thales ATM, as well as Frank Matus, Director, Digital Aviation Market Development for the Americas. Without further ado, please welcome Mr. Warren Beeston. Thank you.
Good morning, ladies and gentlemen. My name's Warren Beeston, and I'm the Operational Authority Director for Global ATM Business Line in Thales. Firstly, I'd like to thank ICAO for offering us, the industry, this opportunity to present our views on the future challenges in the air navigation system and to discuss the popular topic of UTM. I'll present on some of the ATM topics, and then Frank Matus, our Director of Digital Aviation Market Development in Thales, will also discuss the UTM concept of operations, integration and management. My presentation will discuss some of the challenges and the demands in ATM. So, my first point covers the changes in ATM environment and how we'll meet the challenges of the increased demand. The second point will cover the innovation that is currently being employed in Thales and through our research in artificial intelligence. Airspace management is evolving. Airspace management is having to evolve and to respond to the increasing demand from conventional operators, increasing the number of flights through smaller and more efficient aircraft and giving increased frequency to flights. We've also got to deal with new airline operators creating increased passenger demand through low-cost operations in many countries. New operations in low-level airspace, such as UAS, and operations in the upper airspace, above flight level 600, bring specific and real challenges to an environment that has been stable for many years. These operations are being catered for today on an ad hoc basis and arrangements between users and operators. These new systems are being developed and existing ATM systems are being adapted to be able to accommodate these operations today and with a vision to have the operations fully integrated into the future. So we see a change from segregated airspace operations to an integrated airspace where operations are catered for seamlessly. How do we meet this increasing demand and adapt to the changing environment? Thales is working closely with its industrial partners and customers to develop many solutions. There's a need to have a collaborative decision-making platform for airspace management and supervision. This system needs to manage airspace access with authorizations and notifications, airspace management, taking into account static, dynamic and capacity issues, and airspace monitoring with air situation, conformance and alerting. New digital technologies, development techniques and software coding practices will all allow us to create new solutions to be developed more quickly and adapt to a changing environment much faster than with traditional software development. We believe that sharing of information and interoperability of systems is key. The sharing of information amongst stakeholders is the key to interoperability and ensuring that all participants have the correct and same information at the right time. We need to ensure the interoperability of systems and the exchange of data between users is secured. In the ATM domain, this will be between air traffic control and air traffic control, air traffic control to air traffic flight management, flow management, and from flow management to flow management units. We'll also need to exchange data between control centres from ANSPs, airlines, airports, the military, and also with the new players and the new systems that manage the drone operations and the traffic. There are now digital solutions available that enable collaborative aviation operations. Small gains in this area of data sharing will allow improved operations and has the potential to create large benefits. In the tower environment, we've made several system efficiencies. As traffic increases and the challenges for managing environments becomes more complex, we are working with research organisations like CESAR and Eurocontrol and our customers to address their needs with new tools, alerts and working environments. In the tower particularly, technology has resulted in the proliferation of systems, and it's been our challenge to integrate the information from these various sources and create an effective and efficient working environment. New and advanced surface alerting provides much needed safety nets for controllers and airline operations. The full integration of A-Man, D-Man and S-Man into tower operations reduces surface congestion, reduces emissions and provides instant savings to operators. In the approach control environments, there are improvements to the arrival manager functions to use information from an earlier time in the flight to better predict sequences and to minimise last-minute delay to aircraft. The use of extended A-Man will allow ANSPs to further optimise the arrival sequences at busy airports. Additional controller support, spacing tools to assist with the introduction of new separation standards like recat wake vortex benefits and time-based separation. We've also developed additional safety net support for those close operations within the TMA. The development of our time-based separation tools through our extensive research and development with CESAR and Eurocontrol, running over 100 exercises with many European ANSPs, has enabled us to be a provider of the modern solutions to ANSPs that believe that they can achieve additional airport capacity with such tools. The airport capacity improvement is particularly evident when airports have consistent high headwind components in the landing phase. In the en route environment, we've achieved efficiencies with several innovative solutions and several more in development. Advanced medium-term conflict detection, or MTCD, tactical controller tools that provide an alert for potential conflicts in the near term using multi-hypothesis algorithms. We're developing SWIM, flight object and IOP interoperability to ensure that systems share information seamlessly across system boundaries. In development, we have conflict resolution solutions that provide suggested conflict-free solutions to controllers, allowing more cognitive time to process other tasks and therefore increasing traffic throughput. Next generation human-machine interfaces, or HMI. Our new Java-based HMI solutions allow controllers flexibility in their design, setup and use of the main user interface. We've made the interface simple and uncluttered. We've made taking advantages of alerting and non-conformance software to warn the controllers only when required. We're working on developing voice-based solutions to automate some of the controller actions and to further reduce workload and free up controllers to be more effective. How is Thales innovating with artificial intelligence? Well, we're investing heavily into AI research in several areas in ATM. We believe that there are quick wins in the non-regulated area of better predictability in air traffic flow management using machine learning and big data. We're also developing solutions in controller monitoring, HMI optimization, training functions, system monitoring, and predictive and preventative maintenance. Eventually, we will see AI introduced into the safety critical functions, providing assistance before partially and then fully automating some functions. We've already been developing conflict resolution algorithms and had very positive feedback from our customers that have used this function in simulations. noting that workload was significantly reduced and separation decisions were optimised when compared to the same exercises being controlled in more traditional ways. Thales is committed to increasing performance and providing greener ATM services using AI. We see improvements possible in the accuracy of predicting traffic management, optimising flight routing, leading to fuel reductions, predicting unexpected events, improving airport management, and logistical support information. Now I'll hand over to Frank to present UTM, and I'll be back at the end of the presentation to talk about better skies and to take some questions.
Great desired end state, right? So we have a long ways to go before we get there. But good morning, everybody. My name is Frank Matus. I'm the Director of Digital Aviation Market Development at Thales, part of our air traffic management business. I look after the Americas and the growing need for UAS integration into the existing airspace system here in North America. So the overall theme of our presentation is how do we evolve our air traffic management system to bring new users into the fold? How do we enable the industry to continue to grow while maintaining safety and security of all participants in the system? So this certainly keeps with the theme of the challenges of future ATM solutions, and no bigger challenge than UTM integration. Autonomous systems usage is governed by multiple conflicting forces. On one hand, we have economic development policies that are driving the use of unmanned systems into our daily lives, and the use of drones in civil industries has exploded in the last several years, from agriculture to real estate to monitoring construction sites, delivery of critical items for public safety as well as for medical supplies. But on the other side, we also have to deal with a number of constraints that are limiting the growth of the industry. Maintaining a safety-first culture is first and foremost. We have a number of new entrants that have entered the airspace system because they see the upside of the integration of unmanned systems. There's also a challenge that we have with our existing systems and how do we integrate with existing air traffic management. Safety and security of people on the ground. How do we ensure that the the platform itself is safe and secure, and how do we protect the people that are on the ground. So we're thinking through all these different activities, and as we look to integrate new platforms into the airspace system, we have a 10-step process that looks at those critical elements to the safe and secure and efficient integration of UAS platforms. First and foremost is vehicle performance. On the vehicle performance side, we have to ensure that the vehicle meets certain design criteria, certain design standards. How do we integrate with the existing air traffic management system to ensure that if there is an event on board the platform, it doesn't create an adverse situation on the ground? The second is UAV and pilot registration. Much like manned aviation today, we believe that UAS registration back to a real identification source, a driver's license, a passport, should be integrated along with the registration that goes onto the drone through mode identifier. How do we then qualify pilots to fly certain missions? Where can they fly missions? How do we integrate them into the airspace system? The third is ground infrastructure. How do we enable the ground infrastructure to support a number of missions that are taking place in the airspace system, whether they're in rural environments or in urban settings? We must have the ground infrastructure in place to maintain safety critical communication to the platform, as well as information that will protect certain critical infrastructure, and we'll talk more about that in a second. Airspace design. Is the airspace system today, globally, good enough to integrate UAS platforms into the global air traffic system? So today we have a concept called air traffic management. Tomorrow we'll be moving towards airspace management. This is a completely a unique departure from where we've been over the last 100 years as an industry, and now as we accommodate new users and growth, we need to think about how we view our airspace system and how do we accommodate new users. Mission planning and mission approval. Looking back to vehicle performance, the UAV pilot registration and unique identifier for that platform will drive other things, including infrastructure, airspace design, and the mission planning process. Allowing certain pilots and platforms to fly certain missions based on their credentials, their experience as a pilot, is essential to that safe integration. UAV and fleet management. As we continue to grow from a one-for-one operation or visual line of sight, where companies want to then start fleet management or multiple operations from an operations center, we need to figure out a way to accommodate those users and multiple operations from using a fleet management approach. Secure connectivity is one of the critical components that we believe needs more attention. Leveraging existing aviation infrastructure will not help us reach the end state goal of UAS integration into airspace globally. We need to look at commercial solutions like 4 and 5G communications, being able to protect the identification and mission credentials of the pilot and the user that's entering the airspace system will all be a part of the safe and secure connectivity element that's part of this process. Airspace monitoring. How do we leverage our existing airspace system, capabilities, and functions to allow for UAS integration into the airspace? There are a number of components that we can use today that will help us monitor the airspace system, but integrating other new components, new technologies, new platforms will help us ensure that airspace monitoring is consistent across every element of the system. Critical area protection, often referred to as counter UAS. We see this as a major component in ensuring that the public is accepting of drone operations into our airspace system, as well as the protection of critical infrastructure, not just airports, not just power plants, but schools, hospitals, anywhere where municipalities can determine what is deemed critical infrastructure. And then finally, value-added services. So being able to collect information from the infrastructure, the operations, the pilots, to improve operations, to improve flow, to improve how we distribute operations across the airspace system will be essential. So a concept of operations that we have taken a look at, as I mentioned before, we're moving from an era of air traffic management to airspace management. Now there's some commonalities with traditional air traffic management, defining and organizing the airspace, managing traffic flows in an efficient way. Safety and security is paramount throughout the system. Classification of the drone itself or the UAS to receive varying levels of service, just like instrument flight rules and visual flight rules today. or capabilities from a civil aircraft or a military aircraft. Different levels of service will still be provided. And airspace must be accessible to every user in an equitable form. But there are some differences. Control will not be provided on a one-for-one basis. Like we saw in the video, there may be somebody sitting at a location that is monitoring the airspace, but positive control will not be a function that we'll expect in the future with the increased traffic. Multiple stakeholders. How do we get information to stakeholders that are not traditionally part of the air traffic management system today? The military, first responders, municipalities that want to monitor local airspace systems. How do we get that information to their hands? An affordable price for end users. We know that states and countries can no longer afford the capital investment to put the infrastructure in place to support this industry. How do we come up with new business rules, new business plans, new ways to incentivize uses into the airspace system, but also find an affordable way to attract new users into the airspace? Flexible, scalable, agnostic infrastructure and architecture, being able to accommodate users into the existing system, and protection of critical infrastructure, things that I had touched on previously. So you can sort of see here the compare and contrast between air traffic management to airspace management. Some of the data elements that need to be shared across both platforms include elements from the traditional air traffic management infrastructure, being able to distribute special use airspace, temporary flight restrictions, those sorts of things that are traditional in the air traffic environment. The UTM environment may not have an understanding of how that system works today. Airport capacity, runway, airspace configuration, those sorts of things need to be taken into account in the UTM system. How do we manage ports for urban air mobility? How do we know that the port is accessible? Planned and active flight plans and position and trajectories need to be accounted for so that UAS operators understand where manned aviators are, and we don't increase the risk of loss of separation or an unsafe situation in the airspace. Conversely, UTM also needs to share with ATM planned operations, approved operations. Where is the UAS authorized to fly? The air traffic management system needs to be able to understand where these pilots are located, where their operations are, and whether or not they're approved or can have their missions rescinded in the event that an airspace situation arises for an emergency situation or otherwise. So as you can see, there are a number of elements that need to be shared between the ATM and UTM system. This is just the start. So we at Thales are looking very closely at this, and we're trying to figure out the best way to integrate all the platforms that fly today and in the future to ensure that safety of the overall system. So when we talk about UTM and ATM integration, Warren had mentioned that we are looking at how do we evolve our platforms to take into account new technologies. How do we ensure that manned aviators do not face a challenge from unmanned operations and have a loss of separation or an unsafe situation. So we're looking very closely at activities, algorithms, different procedures that we can implement to ensure that there is a safe and secure integration. On the air traffic side, we've already taken a look at migrating our platform to the cloud along with our UTM platform, looking at integration. As we talked about on the previous slide, what information has to be exchanged between the two platforms, and then how do we disseminate that information, whether or not it's an active participant or a rogue UAS that is entering restricted airspace. How do we involve the different participants and stakeholders to ensure that information gets into their hands? So the integration of these two environments is overly critical, and that's what we're facing and focusing our time. So just to close on the UTM side, we really are looking at airspace management instead of air traffic management, and how do we evolve these steps to include UAS operations, not just at low altitude airspace, 400 or 500 feet and below, and not just at high altitude airspace, but look at this as a system of systems approach. The end state goal for us is ATM 2.0, where we see that activities that are being driven by unmanned systems today, advances in automation, advances in route planning, trying to balance traffic between unmanned systems and manned systems, how to bring both systems together is our long-term vision. ATM 2.0 will result in a seamless integration of both platforms and allow for unmanned systems and manned systems to integrate and operate safely in the same airspace system. So I'll turn it back over to Warren for for a few closing statements, and we'll come back for questions.
Thanks, Frank. Thank you. Just quickly at the end, I'd like to talk about a new initiative that Thales has embarked on in ways for us to gather information and help us to build our new systems into the future. We're actually collaborating on our solutions with the air traffic control group as a whole, all around the world. We launched this in the recent IFATCA annual general meeting in Costa Rica, and we're connecting with controllers both that use our system and that don't use our system to give us ideas and work with us together and collaborate and discuss the future of ATC, air traffic management, and airspace management in the future. So we think that engaging with air traffic controllers is a way to help us and help them move into the future in better systems, and that's what we're doing. So we're designing our system in conjunction with controllers. We're having open discussion forums with these controllers, and we're collaborating to invent the future of air traffic management. So I'd just like to say, for those of you that want to connect, we have a number of ways. You can do it through our talesgroup.com website. You can connect with me on LinkedIn, and I'll invite you into the Better Skies Together. We're using LinkedIn as the platform to have this discussion and to promote ideas, ask questions, get discussions going amongst aviation and ATC professionals around the world. So thank you very much for that, and we'll take some questions for Frank or myself.
If anybody has questions, please step forward to the mic.
Thank you both. Very interesting, very informative, and from my background, most interesting to catch up again. Because the first, two questions really. The first one's rhetorical. UAS have been around for 20 years. We're just now starting to integrate them into the airspace properly. Why has it taken so long? That's the rhetorical question. The real question is, how are we now engaging with the UAV industry so that the two technologies move together and are cooperative and work in coordination?
Thanks, Mike. Great questions. And we've worked together for a long time, and you and I talked about this in 2002, 2003 timeframe about UAV, and then I think you were the first to say it really is a system. So UAS is really what we're talking about. I think what we've seen over time is the more capable UASs have been treated more as aircraft. They've gone through airworthiness, design, equipage. From a military perspective, I think there's a much easier path towards integration. I think in recent years, as we've seen an increase in online computing, cloud hosting, a desire for internet companies to move into aviation, we've seen this groundswell that, hey, we can fly these autonomous vehicles to take pictures of rooftops, to do certain inspections, to reduce the risk that we have towards manned aviators to perform certain operations. That's all great. There's certainly a huge industry swell there. But the problem I think that we are seeing as an aviation community is that we have a whole bunch of new entrants that have no context or background in how aviation has come together. We're an industry that's learned, unfortunately, from loss of life, and that's how we have progressed our safety procedures over time. And we have internet companies that show up that can design a great website, and their websites crash, and they go down. If something happens in the aviation system, a crash means something completely different. So a safety-first culture and ingraining that into the new entrants, I think, is important how we move forward. Design standards. Cyber protection, interoperability with manned aviation. These are things that haven't been taken into consideration from a whole bunch of new entrants. I think we're getting there, but it's we've seen the groundswell, and now we're starting to see the industry kind of level out, and we're figuring it out as ANSPs and CAAs and us at Thales to figure out what does that integration actually look like.
No, that's good.
Hi, Mark Millam with Flight Safety Foundation. Really enjoyed the presentation. I like the 10-step plan for kind of defining all the different elements that have to be thought of. And it really sort of emphasizes the whole notion of making this much more dynamic than what we know of today. So kind of with that in mind, I didn't hear the word geofencing anywhere. And I assume that that's because the long-term picture really thinks of these things in terms of a dynamic management of the airspace. But is there some thought to kind of, today we've got some vehicles that we don't want in certain locations, and we need to have some protections for that today. Is there some thoughts on the Thales part in terms of what's the staging in the kind of different mechanisms to get to that long-term picture?
Yeah, excellent question. Probably because it was an oversight in talking about the certain elements. But you look at U-Space as an example. Geofencing is one of the critical components to moving out UAS operations into airspace systems. That's certainly something we're very focused on at Thales. Kind of will answer it a little bit differently in that. Manufacturers today are putting some geofencing capabilities into their products. It's not great. There are some things there to keep the general public away from flying in controlled airspace in places where they shouldn't be flying. It's a start, but it's not great. We need to go further than that. I think as UTM systems evolve, and as you pointed out, it's a collection of all those 10 things. It's critical area protection, but it's also getting information to the vehicles. And I think what we're going to start to see is UASs are measured in terms of years, not in terms of decades, like manned aviation and aircraft. I think capabilities will continue to evolve. Services on the UTM side will continue to evolve. Policy needs to evolve to figure out who's actually going to control that section of airspace. Is it the ANSP? May or may not be. Is it a local municipality that can implement rules and shut down certain areas of airspace because that's in their best interest at a local level? Maybe. Policy still needs to evolve. Geofencing could exist at a national level, which I expect that it would be. And that'll come from a national, our belief is that that has to come from a national authority. That will be published just like airspace maps, just like aeronautical information is published today. From an authorized source, a validated source, that has to get in the hands of the users. And how UTM evolves to provide the services around that on a performance-based operation, I think we're going to see that evolution. So performance will be a result of some of the services that are provided by ANSPs and CAAs. Performance-based access is going to help figure out for first responders or other higher risk operations how people access the airspace system. So certainly a part of our thinking, but I think it's an evolutionary topic. Questions for Warren? He's a very smart guy. He knows a lot of things.
Sorry. My name is Rădmus Dogaru from Romanian Civil Aviation Authority. One question is how to integrate the different part of the UTM, the different part of the solution. The Thales solution for UTM is one part of the story. Another part of the world is develop another part of the UTM. How to integrate it?
From a platform perspective you're talking about, or?
It's a different solution. Some is 5G, some is cloud, some is I don't know how, the different part of the actual ATM solution. How in the future integrate all this solution for global UTM.
I understand. You want to take a crack?
So I guess from what Frank was saying is that we in Thales see a number of different solutions for UTM management. One is that today UTM management tools and systems are being developed quite quickly with new technologies, and we don't see them as safety critical regulated systems like we do in the air traffic flow management. A little bit like the way the UTM UASs are being developed themselves. But as Frank said, we see absolute need to share data between the two systems, so that if we're monitoring systems, monitoring UAS with our UTM system, and we find that they're breaching some of the ATC rules, that we share that information across to the ATM system. And we provide from the ATM system all the current information that's needed, airport configuration issues, all of those things that are dynamic in the day.
So, for example, we have a UTM in Europe, and you have a UTM solution in the United States. How to integrate it to perform over-border flights between Europe and the United States, if it's a not similar solution for UTM?
So I think you have to look at it. So first and foremost, I don't think there is a UTM solution, ubiquitous answer for anything. UTM is still an evolving concept. We don't have airspace regulatory policy around it. We don't have technology that has been decided that it will, like aviation, where we have secondary surveillance radar, primary surveillance. Those are very specific technologies. UTM will be a performance-based system. How do we use a collection of sensors and data to ensure that UTM will be integrated alongside ATM? And I think we're a long ways away from global harmonization and interoperability. Especially today, most of the regulations force us to use visual line of sight operations, right? So if you're flying visual line of sight and you're crossing country boundaries, I think some other people are going to be involved. So I think we're migrating towards that. There's a lot of things that we have to solve first. I don't think we've solved the basic thing, which is remote identification. If we can't identify somebody, how do we allow them to fly in the system?
This is the next question, how to deal with unauthorized flights in your proposal, because will be more flights in this situation. And the last question is how to deal with the hand-manned aircraft, homemade aircraft, because will be a lot, this type of the unmonitored system.
Right. Well, we touched. Thank you for your questions, by the way. We did touch on that a little bit. We need to look at performance-based access to airspace over time to achieve certain services and to gain access to certain elements of the airspace. You're going to need to meet certain performance requirements to do that. Today, it's a radio, and in some instances, it's a Mode C transponder, Mode S transponder. You have to have certain equipage. The airspace system has to evolve. Rules have to evolve to ensure that we can accommodate the growth of the new users. Now, how do you look and maintain air situation monitoring to look at participants and non-participants? We do that today in aviation globally. You could have a busted transponder, but you still have a backup surveillance system to find that aircraft that's out there in a primary radar. You're going to have non-participants that pop up. Is that a great practice? No, but unfortunately, that's how our system works from time to time. We tend to focus more on how do we enable the industry to move forward? How do we write the rules of the road to integrate the active participants? But also take a look at, if you're non-conforming, you may enter the system not understanding that you're not conforming, but you don't comply with the rules of the road. So you're going to have systems in place to protect both manned aviators and people on the ground. So I think the thinking is going to evolve over time, and it's not a clear-cut answer.
No, that's right. But we do have other solutions as Frank was saying, where we've got solutions that do defend against unplanned and unauthorised drones or operators around airports, some specific types of tools that are now new in the marketplace. And, of course, there's the defensive option if you need to go down that path. But that's generally handled by other departments, not necessarily ones that are here today. Thank you very much.
Thank you. Unfortunately, we're out of time. For more information on this presentation, please make sure to check out the ICAO site on YouTube. And if you have questions, please go out there and visit Thales's booth. Thank you so much, Warren and Frank. Great presentation.
Thank you.